Oh, the things. Oh, the things you learn, the sights you see. Oh, the places I'll go. That's the time.
Yeah, don't get us, don't get us shut off for DMCA these days. That is a problem these days.
There are some cool. I saw some cool examples that exist in the community around like DRM and some of the strategies that certain teams use. But
that's pretty cool.
Quite cool. All right.
I think you're live.
Cool. Awesome. Welcome everyone. So apologize for a few of the false starts that we saw there a little bit earlier. If you got excited and noticed the stream started a little early, my apologies for that. Technology is the most fun when it works for you. Welcome to yet another HashiCorp Live. It is Friday and very excited about that fact. If you're just joining us now, please note that our code of conduct is in effect, which simplifies down to please be excellent to one another, default on respect, and just kind of engaging with us in a fun way today. But in terms of things that we're going to be covering today, we're going to be taking a look at one example that we have around Nomad, getting that spun up in the Azure cloud, and installing a few demo applications, and then kind of working with the autoscaler on that front. Now, if you've been looking for some examples of how to get started with Nomad, you might have noticed our Learn platform, and that's pretty easy to do when you're working locally on your own machine. You can pull down the Nomad CLI and get something spun up and running locally. But say you want to get running in a cloud, there are a lot of concerns on that front. So that's mostly what we're going to go through today, is kind of how you do that. We're going to work with the module that we have that kind of exists in the community space, in the public space, and then just kind of go through talking about some of those concerns there, and then ways we can refactor that after we show what this module does and how everything works. So again, happy Friday.
Yeah, I mean, I guess one of the things that was very entertaining to me was that we had a bit of discussion, and we've been having a lot of discussion around a lot of the tools about what does it mean to get started? How long does it take you to go from spinning up something and then getting whatever you need to do? In Consul, maybe it's putting a service mesh together. Vault would be getting a secret. I guess for Nomad, I guess it would be scheduling a job. But all of this, the funny thing was that everybody was saying, hey, in dev mode, I could do this really easily. The problem is I'll spend like 2 weeks putting it on a cloud, which is fair. It's a fair assessment. So we'll see if today we can either reduce that a little bit with these Terraform modules, or we go nowhere, which is also very likely.
Which I've heard is a place, but I don't know about that one.
I know. Well, you were reciting Dr. Seuss at one point, I think, earlier, like a minute ago. So we'll see where we are.
Awesome. All right. Well, I don't have this code published live, so I'll go ahead and do that either during or get that shipped out after. But feel free to follow along with us, ask any questions if there's anything that is helpful to point out. So I'll go ahead and share my screen, and we can let the fun, chaos, and other Friday typed events get started. So you should see a wonderful illustration of Big Sur. I think I've yet to drive down this specific street, but it looks like a lot of fun. So
how do you know which street it is, though? Like, I've driven down the Pacific Coast, but like, which one is it?
I feel like it's just the one. Yeah, if I were to guess, but yeah, maybe, or just this person has a very long driveway. That's that could always be the case too. All right, so I'll actually go ahead and bump up this type so you can actually see what's going on here. Typically, so for those of you that don't know me or have yet to pair with me, I typically I have yet to really get a good sense for all of the key bindings within my VS Code setup. Typically, I still have yet to really use the shell within VS Code itself. I just kind of like having that those two windows. So
what?
Yeah, so I need to up my game.
Okay.
I've also talked a lot with friends that have worked with JetBrains products and heard some awesome cases for using that as well. So still need to make that journey at some point in time.
How dare you? Also, we intend to have some kind of like IDE/tools we use. We get asked about it a lot. We intend to have one. I do want to make note to those who are asking for dot files or something. So Taylor, if you want to distribute your dot files.
yeah, no, that's a great point. I think that for those of you that I've checked out some. I used to play music. Playing a few bands. I used to play the bass and sing and do some other things on that front. So it's like, love it. So much fun. Literally music to my ears. And I always like looking up different band pages and seeing, what gear did they use, what drum set, what mic, what kinds of things. So we can do that too. Not that we'll be doing too much singing on HashiCorp Live, but hey, you never know. All right. So yeah, keep an eye out for that because that would be fun. So when you're working with Nomad, like Rosemary said, one of the conversations that we've had a lot of this week are kind of what are the things that you need to know when it comes to working with Nomad. And when we took a look at that, the answer was a lot, actually. If you want to use most of the HashiCorp stack to get Nomad spun up and working, one of the best things you can take a look at in getting started is using Packer. Now, Packer, you can see I've got the latest version on my machine, which is 1.7.0. This release really puts HCL at the forefront. That's the recommended way to define your Packer configuration now. And there's a lot that's starting to open up now in terms of like data sources and variables, and just defining these things becomes quite a lot easier. So I'm actually going to go ahead and save or get the. See if I can remember my key bindings here and get that nice colorization that I want. Okay, so let's change this to Terraform. So this example I'm going to spin up is going to be using HCL. And as you can see, I'm going to be spinning this up on Azure. I'm going to be putting this into a Nomad resource group, which I've already created in the background. I'm going to be spinning this up in the Western United States, which is a California data center, which is close to me. And then the image name that we're going to be calling this right now is called HashiStack. The reason it's called HashiStack is because it's pulling in the Nomad binary as well as a console binary too, to kind of help unite this workflow that we'll be spinning up together. Now, again, we'll be standing this up and then I can kind of go through what it does and kind of ways in which we can use it. And then with the time remaining, we'll answer your questions. And then the goal will kind of be to refactor this, this is great to have this Packer definition all in one file, but it would be much nicer to break this out and kind of put our variables in a variables file and so on and so forth. So if you see something that might look like a code smell, don't fret. That's something that we'll be getting to here in just a little bit. When you go to work with creating machine images within Azure, you first have to specify the source, and then there are quite a few options that you'll see here. So we're going to be setting our username. We have to provide that to Packer so that it knows, who to create a key pair for, and then how to actually go about logging into that machine that then creates that machine image within Azure. You'll note that we've also defined a few other things here too, to specify what kind of image we want. We're going to be using Ubuntu to install a lot of these things. This var location I've set in the variables. You'll see up here, these all map to these items at the top. And then if we go down further, we'll see that source that we'll define is actually just what we specified here. Nice, again, to use that HCL to be able to break those concerns up. And then we have some provisioners here. So this is actually installing some configuration, which is in the shared folder, which again, I'll share publicly here a little bit later. And just our setup script. So our setup script looks a little something like this. Just pulling in a whole bunch of configuration and details, like we want to download 0.85 of the CNI. We want to make sure that we're pulling in the latest version of Nomad and console for this demo. So those are some of the concerns that are being alleviated here and installed by using Packer, making things nice and easy for us and easy to share with all of you when it comes down to it. So let's scroll
to the CNI download. So I guess like Because myself, I'm not as familiar with Nomad, right? So why would I need the CNI driver, I guess, for Nomad? Is this because just it's good to have it? Is that a newer integration?
So with Nomad, great question. With Nomad, Nomad is nice because it kind of gives you all of these different tools to create a cluster that you can orchestrate and schedule to. But to do that, we need things like the CNI, which is I believe it's a container native interface. And basically what that does is basically gives us an interface to work with, such that as we go to, I'm sorry, container networking interface, that gives us a way to interact with our network and not have to hard code or kind of abide by a very strict way of networking within the cluster. So we install this, and then it makes it easier to interface with different clouds, and we don't have to do a lot of rework on a lot of fronts.
Cool. And I guess there's no Docker then installed, or is that something that we install separately? Because I noticed there's two scripts, client and server.
Correct.
Oh, there it is. Oh,
yeah. Today we'll be installing Docker, Java, and then those CNI plugins that were set up there. But as you can see, definitely worth refactoring some of these steps, because even looking at some of the ways that we have defined this install script up here, I think there's another one that exists down here that we might be able to actually take, like the CA certificates, this new package, and kind of refactor that on that front. So again, this works, but definitely worth refactoring at some point in time, which we'll take a look at today. Awesome. One other thing that's worth calling out is that in another example of this, I saw that there were a lot of sensitive values that were being set to, whether it be a tenant ID, subscription ID. When you go to work with Azure, there's about 4 important environment variables that you'll want to set in most cases. I'm going to be using the Azure CLI just because I'm demoing this, running this on my machine, and to make that authentication, that authorization a little bit easier and more straightforward, I'm just going to define this use Azure CLI auth and simplify our stack just a little bit. So I'm going to go ahead and do a Packer validate, and just actually I'm going to go into the right folder first. Okay. Azure Packer, and that's where I want it to be. I'm going to do Packer validate dot. That's just going to be all the files in that directory, which is just the one file. I'm going to do a Packer build, and then just get that kicked off, and then that will actually go about logging into Azure, spinning up a machine, getting all those dependencies installed and stored, and then actually store the image as a final step. So I'll actually go ahead and pull up my portal so we can take a look there as well. Oh yes, awesome.
It does already exist.
So I built this earlier, and if you wanted to, so for this case, you would want to specify -force to overwrite that image. Best practice would ultimately be that you'd want to, either supply a prefix or a suffix. I know that at HashiCorp we have a lot based around pet names, and like you could get a dinosaur and some other providers and syntax that we could add on this front. But we'll take a look at that in just a little bit.
Yeah. We got a note in chat, which is like to recap what we're basically doing and why we've gone the Azure route. What we're trying to do is we're trying to test this module that was written for auto scaling for Nomad. The problem is that in order to run said Terraform configuration, you have to have the Packer images built. So we are currently trying to figure out if this Packer image works, what is in it. And then we're hopefully going to do the auto scaling, the Nomad cluster with the auto scaling with that correct configuration. If we have a chance, if things are working, then maybe we'll refactor it, because ultimately I think Taylor needs an Azure module for Nomad. I need an AWS one. So we're trying to figure out if we can maybe abstract some of these and kind of develop some more generalized Terraform modules for us to use. So we're hoping this one works. Last week, I think a couple weeks ago, Jackie and Jono investigated the AWS one to figure out if those worked. So the answer was it didn't really work the way we expected it to. So this one we're trying, hopefully we'll create an Azure Nomad, a Nomad cluster on Azure. Ugh, cannot speak. Sorry, everyone. It is a Friday. My brain is like explode, you know. I wish I had the explode emoji. But yeah, Taylor, did I miss anything in that very lengthy description?
No, that was perfect, and really what we're trying to solve here. I think that Rosemary, myself, and all of our colleagues, the reason that we're here is to really help in, if there's a sharp edge or a dark corner when it comes to working with any of these tools, or if there's anything that you're looking for as a practitioner that you want solved. That's the kind of content, that's the kind of experience that we want to provide, because most likely, if you're having that problem and that experience, there's a very real chance that a lot of people are. And some of these tools we're very excited about writing, because we could, we actively want to use them too. So if you have any ideas or questions, or want to talk more in that front, please at us. Those are discussions that we absolutely want to have. So
while it's still playing, I know there's some chatter. Wiring up a provider without using Go. I wouldn't say never. The problem is really difficult, which is why, there was the snobby face. I get it. Yeah. I did try it in Python once, not live streamed. And it was just like reconstructing the schemas, and then trying to get all the code in place to do all the handling was just crazy, right? Because part of it is that all of the providers hold that logic. And if you do write a provider without using Go, unfortunately you have to reconstruct all of the schema logic and everything else. And even other provider ecosystems, like forget about Terraform. Even if you do this in Vault, if you do this in, I guess, Packer, maybe, just Packer's kind of has a provider plugin ecosystem, at least. It's all very Go based. It's really tricky to write it in another language. So I don't know, stay tuned. Maybe we'll give it a try. I can't guarantee we'll get far with it, but we'll try it. If you have a suggestion. Yeah, there is a plugin that will ingest OpenAPI now and spit out a provider. So, it might be easier, but we'll see. I think we could do it. We'll give it a try. Something to, I can't promise it will go well, but I guess that's why we go through the exercise. Yeah, but if you have a language of choice, I mean, I was just gonna try it in Python, but we have this is the OpenAPI one. Yeah. Yeah, I've heard of it before, and I think some folks did mention this to me, and it does sort of work. I think it will depend on your API. And I think it also kind of just depends on if you do it in your own language too. If you do it in your own language, like, I think someone's tried. Someone's joking, gets to kill a dream. There must be hope first. Yeah, I know. We're fighting the good fight. We're gonna try to hopefully get something. If not, and Go, hopefully the Open API thing will hopefully make it easier. How long is it taking you to unpack this? Goodness gracious. How many scripts is it running?
Just like all of the scripts.
Oh.
I think this typically it takes around like 5 minutes or so, but yeah, I can always bail out and use the pre-built image that I've got if this gives us any more problems. This takes a while. On the note of programming languages, I was in a meeting earlier today, and I think one of my favorite quotes about programming languages in general is there are two types of programming languages: the ones that everyone complain about and the ones that no one uses. And I absolutely agree with a lot of the sentiments there. I think that's pretty funny.
So something I heard from Kareem this morning. So for folks who are not as familiar, Kareem is occasionally on this channel as well. We were chatting back and forth this morning, and something he informed me was that there's actually like a line of code or something to like in Packer to deprovision something deprovision something in Microsoft, right? Or in Azure, right?
Yes, yeah, I was talking with him about that earlier too, and I think it involved I forget what it was, and I don't have the example in front of me, but he showed me when he was screen sharing, and it was it involved an apt-get update that you have to run too, and we were both like, that's interesting, that's something that you have to do to deprovision, but awesome. So I think this is mostly done. What I'm going to do to save you, you could watch the terminal scroll just about all day, but I'm actually going to jump into some of the Terraform, and I can kind of talk to some of the items there that we're actually going to go and going to be consuming. So one of the things so this example is based in this control folder, and that's to control the Nomad cluster. Now you'll see that there isn't too much in here, and the reason is because we have all of our Terraform defined in one file, which we're going to take depending on our time left, breaking this out and refactoring this a little bit, so it's a little bit easier to follow along with. And then down here,
oh, there's a couple modules in here. I didn't even know there were like 3 or 4 modules in here.
There's quite a few. We have our HashiStack jobs, which are going to be all of the services that we're going to be running on this Nomad cluster, and then the cluster itself, which through a few iterations, I found that there were a couple options that were defined within this module, and that was building the HashiStack image, which will actually use Packer to do what we're doing over here, where you saw the green flying by. And then we want to set, the actual resource group that gets stood up in. Otherwise, it just assumes that you don't have one and creates one for you in real time. If we want to go ahead and take a look at those modules, you can see that's where a lot of the provisioning and all of those concerns are met. So if we take a look at these servers, we can see in Azure, for those that I'm most familiar with working in Amazon personally, that's just the most experience that I've had in all of my N-1, N-N jobs is mostly working within Amazon. And so I'm familiar with like auto scaling groups as the resource that I typically use. In Azure, you're going to be standing up virtual machines. I think it's a server set that actually gets stood up, and that has that same auto scaling group type of effect. And then in here, we're setting up security groups and load balancers to expose all of these services. And then lastly, we're using some Active Directory features to be able to read information from Azure to actually auto join our clients and our servers together. Now we're going to stand up one initially, but we're actually going to we're going to start with a very small footprint, and then the autoscaler allows for us to expand our workloads either both at the application level and at the actual server level too. So as we add more machines with the amount of load that we're putting onto the server and that the service is consuming, that's going to expand, which will be kind of fun to demo with you.
So I guess my question is, like, as the Packer is building, is this module basically picking the script that's getting run as like how exactly is it choosing the server, right? Because I see servers.tf, I see clients.tf, then there's network.tf, and then net.sh. So which ones is it picking, like which script it's supposed to run when Packer comes up? Like how, I wonder how it's being defined.
Absolutely. So what Packer's doing, Packer's going to give us this, which it looks like it's just about done. So it's capturing the image, and we'll shortly see that. I think actually I've got that right here. I can type in images. And what Packer's going to do is give us this machine image, this HashiStack image here. And then we're going to take that and use that as what we're actually going to run within that virtual machine. And so Terraform is going to go ahead and handle, it's going to take that image and then use it to stand up most of the infrastructure. All of our compute infrastructure is what it's going to be using. Terraform is then going to go ahead and handle what's on the network, setting up our network, our security group rules, our clients, our servers, generating the SSH key that we would need if we wanted to log into the machine, things of that nature is ultimately what the Terraform is doing. So it's taking all of that effort and kind of concentrating it into what's going to be our Nomad cluster here in just a second.
Still thinking. I see local exec.
Yes, and if you've seen local exec before, I definitely have quite personal feelings on local exec. It's a really helpful
Do
tool.
tell me those feelings, Taylor.
Like, oh,
We're not.
it's like, yes, yes. With local exec, it's my personal take is it's best to not use as much as possible, just because when you're running a script, when you're using Terraform, it's something that you're being very declarative about. You have you're pinning your versions in most cases. You have an idea of what you want your infrastructure to look like. And Terraform is a great infrastructure as code and a provisioning tool. When it comes into looking at configuration management, however, there are tools that can be a little bit better in doing that job. Or you can kind of create images where maybe you set environment variables and then use that to kind of go about configuring the services that you have on your machines. The 12-factor app, I think, is kind of the probably the closest way that I think about a lot of infrastructure and just ways to make apps pluggable as opposed to having things that are hard coded. So so with this, my want would be to refactor this such that we might be able to set this within the machine image itself, or whether that be cloud init or something like that might be a neat way to go about refactoring something like this.
So this is, did you generate this then? Like, if so, do we have to generate this before you run the Terraform?
No. So
I guess we're going to try it now.
Yeah. So we have our image. We're good to go on the Packer side. And to show you, I've got no tricks up my sleeve just yet, at least right now, maybe later. But we have our HashiStack image that we got created. So that is all good to go. And now that's the only dependency that we need that will exist outside of Terraform. So if we go into our Terraform folder, we go into that control folder. I'm going to go ahead and do a Terraform init just to go about pulling in all my modules, making sure that all my dependencies are there. I ran this earlier, so we don't have to wait too long on that front. If I do a Terraform format, that's always nice to do to make sure that you've formatted all your files correctly and everything is the way you want it to look. We run a validate, that makes sure that all of your syntax and your dependencies and everything is linked together all right. Make sure that there aren't any silly errors or anything like that that will come up during your plan step. Go ahead and run a plan.
Yes, and someone mentioned this in the chat, like you could use Vault to actually deal with the private keys and then inject them in Terraform. Unfortunately, there's not really a direct integration to go from Vault direct pass into Terraform, other than to use the Vault Terraform provider to retrieve the private key potentially. So just be aware of that. But yeah, you could use Vault to do it. Good suggestion. I highly recommend, especially because private keys are a pain.
Oh my goodness, they truly are. And it's nice to use Vault because you get that one-time, you can either get a one-time password and you can just in time, protect your assets. Awesome. So our plan looks good. We have about 50 resources to add. Let's use the power of Terraform to make that happen.
Too bad we're not counting pebcaks, Taylor.
Darn it.
No, we have a 5-second. So for those who are not as familiar, we have Pebcac Monday really, really early in the morning, which is basically me stumbling about without coffee at really early for me. And so we have a rule now that if it's under 5 seconds, it doesn't count as a pebcac. So I don't know. We may change it. I don't think we're going to change it, but
yeah. I'd be down with like 5 milliseconds, and then you get to see those pebcacs increase.
Pebcac counter.
All right. So this example, we'll be using my local authentication. I haven't hooked this up to Terraform Cloud or anything like that right now. That's definitely a good thing that you could add in there, and then I could store some secret variables and other kinds of configuration and types there. So that's definitely also something that we can take a look at here.
Okay, so this is promising. This is a little further than what we got with the AWS module. We're actually running and there are no errors. So that's promising. I'm still kind of wondering, like, is this they're on private subnets, public subnets? Like, I know that there's probably some security groups thrown in there too.
I'm just going to take a look. That's a good point. I believe that these are on public subnets, if I'm not mistaken. That's one thing I'd like to take a look at too, is seeing. So I think, so these are stood up in private subnets. And then I think that we do have a public IP that we set to be able to access this. So these are set up in private subnets, but then exposed publicly and have a load balancer as well. So.
Okay, wait, so then why would we have a load balancer to public instances? I guess both servers and clients are public, or just the servers are public?
I think the way this module is set up is such that it routes. Let me take a look at the Terraform outputs actually, because we get our public and private addresses here. I know that it stands up the servers through one method and then it exposes the clients another way. So I believe it's the clients that are actually exposed through the load balancer. That's where we set up the security groups to access our what we'll see is our demo application traffic, which we'll be using to route our traffic and some of the other concerns on that front.
Yeah. Okay. I will say most of what I've been putting everything in private subnets, as one should, for security's sake, and then putting public load balancers in front of them. The problem is that I have a really difficult time debugging, right? Because now I have to figure out how to get to the private subnet. So out of either genius or sheer laziness, I decided I would just deploy Boundary by default. So now there's just I have a bunch of Boundary instances. It's because I basically don't want to create my own Bastion Terraform configuration for bastions. So I just create an entire Boundary cluster just so I can like go debug my private instances, which might be overkill, but Boundary works great. So I'm not complaining. But I was like, that's why I was curious. I was looking at this. Is this public or private? Because if they're private, we wouldn't be able to log into them, which is why I guess the PEM is there in the first place, because then that means we can actually log into it if they're publicly available.
I think I'd have to go through the code to see, but I think it might be that kind of use case is what's intended, is that you can, it gives the public IP and then it does, there is code that actually captures your IP and your /32 address. So it's just your computer. And I believe that might be the security group rule that's allowed in the allow list, so that you can SSH into the machine and troubleshoot it, but then, and that's public to you, but then the rest of that is kind of blocked out and blocked for other traffic that's trying to come in.
Yeah. I also think, because I saw this module, which I didn't even know was a module that existed. So I learned something new. There's like a client IP module. So it like gets your IP address. And it must be adding it to the firewall rules to limit it to your laptop, Taylor. Like it must be reading the public IP off your laptop and then adding it to the security groups or network groups, I guess then. And that way you can access it, but I would not be able to.
Which is kind of cool. So yeah, there's our public, there's our private, and then that gives you the ability to log into that system and then troubleshoot, just like Rosemary said. I still have to take a look at Boundary and get a couple examples set up, because I much prefer to use that and I would find that a much easier tool instead of having to have that Bastion host kind of sit around and be consuming our billing and things of that nature. But cool.
Oh, this is interesting. So Grafana is also deployed. Traefik is deployed. Prometheus web app. So I know Jackie, another one of our, at least the Nomad sort of specialist in the team, was mentioning that there's like an ingress that you need to deploy as part of Nomad. I guess Traefik is the one that's being deployed.
Correct.
Looks like. Okay.
So that one's going to go ahead and set up all of our Grafana endpoint, Prometheus, the traffic endpoint, which is this right now, which you can see is 8081. And then our very elaborate web app here that just is a static page that serves up some HTML. That's that web app is here. Oh, nice. Bad gateway.
Is this our first? Is this the first thing we got to debug?
It looks like it. Let's pull up Nomad.
So something's broken.
Let's see what's going on. I've noticed that too, that in a few times that I've started things up, we've seen what is it? The Grafana also, I've gotten that issue as well, which I'm kind of curious to see if it's loaded up now. Yeah, okay. This is what I'll typically see. It takes a little bit for Grafana to get started because it comes with a prepackaged dashboard that you can look at the requests coming in and see all of the 500 errors and things of that nature. So in some cases, okay, there we go. So it just took a little bit of time. So okay, don't have to debug that one.
This doesn't have, oh, it does have console enabled too, right?
And then I'll jump into that as well. And this is our console cluster. So we can see all of these registered services, which is nice. And then our nodes is just going to echo what we have here. So we've got one client, one server, and then we have all of these services which were registered by Nomad because we're using the console agent to do so. So yeah, sorry to disappoint on the on the debugging.
That's bad.
We
could debug it. No.
we do still have Grafana, which again I think takes like I was following the logs earlier, which we can do here and kind of see what's going on. But let's export out these so we can actually go ahead and connect with our Nomad cluster. Let's just get all the members so we can see we have our one machine. Nomad node status.
Okay, so I guess this is one thing that if we were to think about what you would need, like for our use case, we probably don't want one server, right? For us, when we're demoing, we probably want to actually show a couple of servers. So something right off the bat is that we probably want 3 servers and not one. And I don't know if that is something is it something you can change within the module or within this configuration?
Yeah, let's check and see. I know that, let's see here. So within servers, so this does say var server count. So it does look like that would be something that we could edit. Let's go into our variables and we do have server count. So we could adjust that. We could change that to 3. And then, so we could go in here and then within our module definition, we could do this and then we could change that to 3 and see what that does. Plan. Let's take a look at what happens there.
I don't know if we need to scale it up right now.
Cool.
But something we probably, it's nice that you can customize it though.
I'll go ahead and take that out for now. One thing that we have in this repository is this autoscaler job too, which was not installed initially, just to kind of the intent being that one of the teams made this to kind of allow you to stand things up and then just kind of get a sense for what the job file, that spec looks like. So we can see that we're going to, this is the job itself. This is going to handle auto scaling when we go about simulating some traffic to the cluster. We have, we've got this wonderful demo application and we're selling it to the world and we're preparing for launch day. So here's a task, just some mostly straightforward things when it comes to the actual application. We're installing a Nomad Autoscaler 0 through 0. If we scroll down here, we get to see some of the basically what we're looking at in terms of when do we want these things to scale. So I think that's a little bit further down here. So we can see that when the memory exceeds 70%, that's one context in which we want to scale up. And then I think that there's some other items here too. So this will not only scale just the application service itself, but also the server and the clients and that level of the stack as well.
So mostly because you're more involved. You're involved in the Kubernetes community. I am probably a little bit more familiar with Kubernetes, but this is basically combining cluster autoscaler as well as horizontal pod and vertical pod autoscaling, like all together in one place. Correct.
Yeah, correct. So that is it, and it's using some of the same technologies too. Like you would use Prometheus, you'd be able to use Prometheus within Kubernetes, and then kind of use that PromQL and that query language to set in which at what point in time to scale. But yeah, you absolutely agree with what you said in terms of combining those two types of auto scaling together.
So we had a question in the chat, and does the data center value in Nomad match the data center of Consul?
Yes, so that does here. You'll see DC1 here, and then you can't even go over to the UI, and you can see. I believe there's a way to see it. So yeah, so we have our data center DC1 there. and then we can see DC1 is there.
I guess the better question, one of the better questions that we probably need to dig deeper into is whether or not it could mismatch, right? Like, does it have to be matching? It's a really good question. I think that someone answered this before, but I don't remember. We have it somewhere somewhere. I don't even remember where, but we have it somewhere, whether or not they could be mismatched. But I think they have to match, especially if you deploy Consul Connect as part of the Nomad cluster.
Interesting. That makes sense to me. Yeah, I've always just out of habit kind of always set those to be the same thing. So I think that's a great question. We'll have to check that out and see if what happens when we don't. Awesome. I'm going to go ahead and so to run a Nomad job, you can do Nomad run. And then I'm going to go ahead and add that auto scaler, and we can see that everything that got pushed up. I can go ahead and even check out the UI and see that we have now our auto scaler and everything. So we have our whole stack running. We've gotten Nomad set up. We've kind of walked through that code and have some good ideas on things that we can change. And then let's take a look at the last component of this and use a load testing tool, which this one I'm going to be using is called Hey. And really, I think it replaces Apache load something. I'm going to actually pull up that repository. But I was not aware of this tool until I think about like a week or two ago. But yeah, whoop. There we go. Hey there.
Oh, hey. What?
So yeah, what was this? It was, I think it replaced Apache Load Bench or something like that. So yeah, Hey was originally called Boom, influenced by this tool, and using the same name was a mistake, and name conflicts. Okay, so yeah, so that's interesting history on Hey, but yeah, I had no idea about this project until just about last week. But what we're going to be doing is I'm going to kick this off, and which will simulate traffic to our Nomad cluster, to that web service. So we'll start to let's take a look to see if our Grafana.
That's like another one that I've heard. Someone introduced me to K3s, which seems very similar. Hey is also another one. It seems like there's new ones coming out.
I like the under 5 characters tools because they're for me personally they're much easier to remember. Awesome. So Grafana did come up, and we can actually start to see right at the moment in which we started to really start to stress test our cluster. Some of these things that are in this dashboard, so we can take a look at all of the clients' CPUs, in which we can see this one's spiking, which is not normally good, but in this example, this is good because we want to see if that auto scaler works. We're also able to take a look at the memory, which, oh my goodness, yeah, that's really spiking. So again, not if you're an SRE, this might give you some worry, but don't worry. This is everything as expected. If we start to get to the point where it's too many requests, or we're in the middle of scaling up, we might even see some 500 requests. If we don't, we can actually push our cluster a little bit more heavily here too. I believe that this is concurrency is the C, so that's going to be 60 things generating every single second. This will be over 10 minutes. I actually can't remember what the queue is. I'm actually going to take a look and see what that is.
Is that a horse or a donkey?
Cow. Cow say.
Oh, it's a cow. Oh, it's a cow.
I used to pipe it to Fortune, and then it would always I get like an inspirational quote or something like that. But yeah, something stopped getting supported, and I just put.
You can tell I am not up to date on pop culture. I have learned many new terms this week.
Okay, so Q is rate limit, so it's not going to exceed 40 queries per second. So we'll have enough. So we're kind of bottlenecking there at 40 requests a second, but we have the 60 concurrent connections to kind of simulate some traffic.
So I guess this is something that I am reconciling, right? So if you were creating something like this in Terraform, where you say like, hey, let me get 3, or in this case, 1 server instance, maybe 3 client instances, and you've got an auto scaler turned on, and it's now scaling clients, right, from like 1 to 3, which is now no longer in your Terraform state. How do you reconcile the two, right? I have my opinions, but I also know you probably have your opinions on this. How, how does someone consider that as part of their, does it violate infrastructure as code? Is it better? Is it worse? Is it a good pattern?
It's something I've been thinking about. I really don't have a well-formed opinion on it just yet. I'd say if I were kind of put on the spot like now, like what do you think? I would say it's
oh
really.
No, I'm sorry, Taylor.
Oh, you're totally fine. It's something I wrestle with because it's such a great question. It's I've seen that in the Kubernetes space where, yes, I'm starting to see some 500s here as well. So that makes me kind of happy. It's interesting because you can do everything with Terraform, right? But just because you can doesn't always mean that you should. I can eat like this, but it becomes a very difficult dinner table experience with my family. But I'd say that there are certain things within Terraform where you can set, and it's in the Terraform lifecycle. You can ignore certain things. If you have something that auto scales, you can ignore that, and in some cases, I think that that's okay. But in others, it can be difficult because depending on your application, you might, be working with a bunch of ads or a bidding service or something like that. And you really don't want to mess with that, right? Because if you distributed this compute and it's working on some data that you need ASAP, you don't want to accidentally scale that in and kind of mess up that job run, right? So when it comes to Terraform, I've seen situations where we stand up the infrastructure and then we just kind of ignore these values because at the end of the day, the cluster is smart enough to manage itself at that level. And that kind of is a blurred line when it comes to configuration management as well. What do we want to enforce with Terraform, and then what do we want to leave up to another tool? In this case, I think it'd be great to leave that management up to the Nomad autoscaler because it's able to scale up this web app, which it's brought up to 6 now. We just defined 1, now it's up to 6, which is quite nice, and I think it's worth leaving that to Nomad in this specific context. And then we have these clients here. So it looks like one of them might have gotten overwhelmed and kind of pulled out of the queue. So we're at 1 and we're at 3. And then we have this server as well. But if I were to turn this off and get rid of this hey command, then it's going to scale back in, which is great. It's going to save me on cost. And really just for my use case, this makes a lot of sense. But all that to say, it depends, which is my most favorite answer to give in tech, but also the least helpful and my least favorite to hear whenever I get that answer to that question.
Yeah. So you said one of the clients dropped, right? Is that what happened with the, okay.
Yeah, it looks like, and I saw that too, where you saw, 1, 3 back down to 2.
Yeah.
And I'm not sure how we'd go about actually taking a look at that other than, what we're able to see here in Grafana. Like we can see all of those IPs. You can't see me pointing at my screen, but all of these IPs here, and then just some other helpful information here as well. We can also see that, actually, if I change this to the last 5 minutes, that might be a little bit better too. We can see that now that I've stopped that, hey, I'm not DDoSing us anymore. So now we're able to see that load kind of drop off, and we're able to see more green on our charts, which is good to see. And then I think that this is set to 30 seconds. So after about 30 seconds of this reduced load, it's actually going to start to scale back in.
Nice. All right. So what's next? So we confirmed it does work the way we think it does. I guess some of the things that I'm learning is that it's nice to have, like, if we do like our own starter, it is nice to have Grafana and some sample example application that's on there. It is kind of nice. It doesn't have to do the scaling stuff, but at least it should just show like, hey, here's an application. I have a job scheduled, and then there's the visualizations. So it's maybe something we consider. But what is next? Like, what do we want to do with this module now that we know it does work?
So now that we know that this works, there's quite a few things that need refactoring. You notice that like most projects during crunch time or during the end of the project, it's all about let's get this working. We can fix this tech debt a little bit later, and so there are areas where we do know some good patterns, and we're kind of able to refactor in a few areas. And so, I think one area that I'd like to take a look at refactoring is, the network module is kind of one that stands out to me, because we have Terraform registry, which we have a lot of public modules, verified modules, and instead of standing up these resources and managing these things directly, we can make use of specific versions of some of the Terraform modules there. And then also, like you pointed out, we generate a PEM key, and we can ask that question: do we need that? Can we generate that later? We didn't have to, thankfully, log into the machine, but we do kind of want that ability. So this might be something V2, V3 to take a look at and to refactor. But when it comes to the Terraform layout, I think that's usually the next thing that I typically like to look at and inspect and see if there are areas that we can refactor when it comes to some of these definitions.
Cool. So something that someone brought up was they asked the question about the data center values and Nomad matching the data center values on Consul. I actually pulled up a GitHub issue that Tim answered about the difference. It turns out the terms don't match one-to-one. And so you could have Nomad clients registered in data centers like within the availability zone. So since we're using US West, right? I don't know, what are the availability zones equivalents in Azure again? I mix them all up all the time.
Same. I think it is availability zones. And then I don't know in terms of like subnets. So yeah, my brain also kind of like locks on region, availability zone, and that kind of distribution.
Yeah. So in theory, you could have the data center doesn't have to be one-to-one with Nomad and Consul, because Consul could just encompass the entire region, for example. So I wonder, could I change like the Consul data center using this Terraform module? Could I change the Consul data center?
Yeah, absolutely. Let's take a look at that actually.
I'm just curious what happens.
Yeah. And so let's take a look. We actually see where the heck we set this data center. So let me start by looking at the Packer configuration, because it might even be there. Actually, I want to take a look at the script. Sorry, everybody, for jumping around so wildly for a second there. Let's see. When it comes
digging through, I mean, I'm tempted to just like Control F DC1 and see where the instances are of DC1. The config, I think it might be under Packer config or something as well too. So
there it is. Find files. Okay, so we want DC1, and let's see if we can see that anywhere. Okay, I see it there. I see it in Terraform state. I'm not seeing it in the configuration though.
Dun dun dun.
It's like, where did it
go? Well, perhaps we've learned something new. I wonder if it's something that if we don't specify a Consul configuration, right? This might be something that Jono mentioned to us before, who's another one of our teammates, but if it doesn't specify a Consul configuration, it just defaults one somewhere. So is there a Consul config? Oh, Consul config directory. Where is the Consul config?
So it doesn't look like it adds it. So it's I can actually just confirm, make sure that are we moving anything in here? There's the Packer config. All right, so we have our systemd file here, but what about our server sh? Yeah, I don't think I see
console.hcl. Scroll up. See the sed line 31. There's a console.hcl, but something is getting written into the IP address server count and retry join. Retry join is an indicator that it's a console. Yeah, DC1 is the default. I wonder if the default, if there's even a default config, or there is a config in general being written, right? Because it would just default to DC1, but I'm wondering where this console.hcl is. So either that or because it is doing a replace somewhere. So where is it?
Let's see. Config directory, console client, HCL. So yeah, just jumping back and taking a look at basically for those of you that haven't done this, yak shaving is I think the closest word I can think to, trying to find where this is actually set.
Because it's got to get copied in somewhere, right?
Yeah, and I would almost think it'd be in this Packer scripts. Oh, here's some.
Oh,
Okay. There we go. Much better.
yeah. So it is just using the default DC data center, which is DC1. So you could add a DC config in here somewhere. So we could try that and see if it reprovisions. Although I don't know if you want to deprovision everything.
Sure, yeah. I do love a good Terraform destroy. Not gonna lie. I think that the way this is set up too is such that we'd have to rebuild the Packer image as well, and then redeploy the stack. So that would take a little bit of time, but and also something good to think about too when you go about building your infrastructure how are ways in which you can abstract each of the different components of your stack, or maybe we might be able to make some of these values pluggable through environment variables, and we can kind of set things with cloud init or those user data definitions when the machines start as one option, or use something like Ansible even.
Yeah. Okay, so this is really interesting to know though, like bootstrap expect, for example, the server count. So this is where, this is server count and not client count. So that makes sense. So it's basically saying if you had 3 servers, which we did mention could be something passed in, then it would just replace 3 in there. For those who are not as familiar with Consul, basically Consul has expectations of how many liters it will have. And so bootstrap expect must match the number of liters expected. Okay. I guess we could, this is still pretty decent.
And good to know. Yeah, today I learned, and to give more context to those of you that are watching, this is a few public examples that we have, and so that's why some of the lack of familiarity and why I can't answer those questions directly is, and just makes it more fun for HashiCorp Live on Fridays and just kind of debugging and trying to find some of these items.
Yeah, I'll put the repo in the chat for those who are interested in digging through it. They have demos for GCP, Azure, and AWS. Okay. Well, I guess the question is, do we want to refactor this module? Is this something we start from scratch?
I think so. I think that when it comes to refactoring this, so the way in which we called this today, this is basically set up to be a module, and then we kind of pull this into this Azure cloud example. I think that next steps are really to we can take this module and then it honestly be nice to make this its own module, publish that to the Terraform registry, and then make that easier to kind of consume, and then potentially make some of our own examples on that front. So we definitely have a good foundation here, but there's definitely a few more things that we can do, like you said, to like we can remove access to it, maybe implement boundary to kind of get access to the machine, clean up some of these security groups as well. Here, like we do have 22 exposed to my machine, and then with 4646, which is Nomad's default port, that's something else I'm able to access. But if we take a look at some of the client, I think is it here? For some of the security groups, we kind of have to know the application ports before we actually stand things up. So like traffic, like Prometheus, and kind of allow those items. So that's something that might be worth looking at too, is kind of finding if there's a way that we don't have to know that explicitly, or your team wants to come up with an application that is exposed on port 10,000, something like that.
Yeah, I will say I don't, I know that the baking the console config makes it easier, but I do wish the console config was abstracted abstracted out to the module level rather than in Packer, because I would want to be able to change it. I know that it is not the best thing, but if I'm using this and I want to if I want to change the data center or I want to reorganize some things, I still need enough flexibility to change those configs.
Absolutely. Absolutely.
And it takes a while to provision Packer.
And it'd be nicer if we could just set that as, as value in Terraform and then spin that up, so you wouldn't have to wait that extra, 5 to 7 minutes to spin up Packer every single time. Awesome. Well, unfortunately, I think that we're just about at time, but happy to answer any more questions if you have them. This is something that we're going to continue to dig into, and have started some work on looking at this module and ways we can go about defining this. So I think that we're pretty close, right? We have something that's working. Really is just something that needs to be cleaned up and then made a little bit easier to extend. If we wanted to, maybe we don't want to have our console cluster defined within these pieces of compute. Maybe we actually want to have that separate and provide an endpoint instead, or do the same thing with a Vault cluster as well and get that level of functionality. That would be quite nice to have. So definitely things that we're going to be taking a look at in future HashiCorp Labs.
Yeah. And for those who are in chat, thanks for dropping questions and doing the research with us. Appreciate it. And also thanks for the folks who had some suggestions on trying some things and breaking and debugging. I think there's some requests for that we probably need to try out, which is like changing data centers, getting the right settings for Consul and Nomad. I don't think we've ever shown, at least not on a stream, how we get Consul and Nomad working together, which is probably good. And also a Terraform provider with a different language, which is extraordinarily difficult, but maybe we're up for the challenge. And in terms of anything on the stream in the future, we have one on Monday. Kareem and I are going to be debugging. I cannot get this to work at all. I've been struggling. It's a Consul terminating gateway to a Postgres instance, and it is just it's got like connection refused. It's going through the proxy and it just keeps coming back as connection refused, and I cannot figure it out for the life of me. So we're going to try to debug that on Monday and actually show some of the sort of end-to-end zero trust system that I have that is currently like not really working. So we're gonna hopefully get it working. We also have a bunch of community office hours on our YouTube channel next week. So if you have questions about more specific tools, feel free to check out the community office hours. Anything else I missed, Taylor?
No, I think that's everything. Again, feel free to add us if there's anything that you think of or any questions that you have. Feel free to check out discuss.hashicorp.com. Is a great place to raise some of those questions, and check out other things that other practitioners might come across, or questions that people might be going through, as well as learn.hashicorp.com. If there are any tutorials you might want to see, please let us know. But there are quite a whole host of tutorials and other pieces of content there already, and different learning tracks. So if you do want to, like me, study up on Azure and some potential things you can do with that using Terraform or Consul or Nomad, feel free to check out what's on learn.hashicorp.com. And I think that's it. I hope you all have enjoyed the stream, enjoyed learning along with us, and that you have a wonderful weekend or week in store. Awesome. And with that, we'll see you all next time. Have a good one. Later.